Hi class, we are now on 11.3. In chapter 6, we introduced two common types of reactions that take place in aqueous solutions: precipitation and acid-base neutralization. Before moving on, let's briefly review these reaction types and then preview another type, which is metal displacement reactions, that also takes place in solution. Precipitation reactions. In precipitation reactions, two solutions combine to form a solid product. For example, aqueous silver nitrate reacts with aqueous potassium chloride to produce silver chloride as a white solid. We can write a molecular equation for this process like this. The driving force of this reaction is the formation of the precipitate. We can also express this reaction as using a complete ionic equation. In this reaction, potassium and nitrate are spectator ions. They are not involved in the formation of the solid. We can remove the spectator ions to show that this as a net ionic equation of silver plus chloride produces silver chloride as a solid. Precipitation reactions depend on the solubility of the products formed. If two ions can combine to produce a product that is insoluble in water, a precipitation reaction will take place. This chart from chapter 6 shows the solubility of many ionic compounds. As you can see, blue is insoluble and yellow is soluble. So you can go through and find what you need and then go across to what the metal is, and you'll see if it is soluble or insoluble. In an acid-base neutralization reaction, an acid combines with a hydroxide base to produce water and an ionic compound called salt. For example, hydrochloric acid reacts with magnesium hydroxide to produce water plus magnesium chloride. The driving force of a neutralization reaction is the formation of water. Neutralization and precipitation reactions are both examples of double displacement reactions. We will cover their other reactions in chapter 12. In metal displacement reaction, a solution containing the ion of one metal reacts with the elemental form of another metal, which means a solid. For example, if we place a copper bar in a solution of silver nitrate, the copper metal reacts with the silver nitrate to produce copper nitrate and elemental silver, meaning a solid. We can show this as a molecular equation or as a net ionic equation. We can write a molecular equation for this reaction like this: copper solid plus silver nitrate in aqueous solution produces copper 2 nitrate in aqueous solution, and 2 moles of silver solid. Or we can write a net ionic equation of copper solid plus ions of silver produce ions of copper plus 2 moles of silver solid. These reactions are examples of single displacement reactions. These reactions will be described in more detail in chapter 14. Let's briefly summarize these ideas. Precipitation reactions involve the combination of two solutions to form a solid product. They are double displacement reactions. The formation of the precipitate is the driving force for these reactions. Acid-base neutralization reactions involve the combination of an acid and a hydroxide base to form water plus a salt. They are double displacement reactions. The formation of water is the driving force for these reactions. Metal displacement reactions involve the reaction of an elemental metal with the ions of another metal. These are single displacement reactions. We'll discuss the driving force of these reactions in chapter 14. So basically what you see is you start out with a metal. Elemental forms means solid. So this one is a solid, but what happens is they switch places, and now this one's a solid and this one is joined as a nitrate in ionic form. So precipitation, acid base, and metal displacement all happen in solutions. Two solutions combine to form a product. This is something that you should already be familiar with. When aqueous copper nitrate and aqueous sodium sulfide are combined, a black solid forms. Use the molecular equation, write a complete ionic equation and a net ionic equation. So here are the answers to those. You should be fairly comfortable doing this by now. Predict the products from these precipitation reactions and balance if needed. So I'm just going to give you the answers to these. And acid-base neutralization, it's a base plus an acid. It produces water and a salt. Predict the products from these neutralization and balance. So I'm just going to give you the answers to these. And metal displacement. An ion of one metal reacts with an elemental form of another metal. And we can put this in. You can see double displacement. It asks for, we have precipitation, we have acid base, and then we have metal displacement. And the driving force is a precipitate on the top one. The second one is water, and metal displacement, they're switching places. What type of reaction is this? So if you look, there's a metal, and then it produces the other metal on the other side. So this would be a single displacement reaction. You could look at it as A plus BC, and then you can see that this is B and this is AC, if you want to look at it that way. So this is metal displacement. Predict the products from this reaction. So I'm just going to show you the answer, and hopefully you're understanding. If you label again A plus BC, will be B plus AC, and if you can imagine it the way I'm stating it, you should be able to see how it's switching partners. When an aqueous solution of sodium chloride and lead 2 nitrate are mixed, what solid precipitate forms? So this is a double displacement. They switch partners. It's going to be lead chloride, lead 2 chloride. What ionic compound results from the reaction of copper metal and aqueous silver nitrate? So this is a metal displacement. It's going to be copper nitrate.